So today we're starting a new topic, though the topic here is incorrect, circles. How could we graph a circle centered at the origin? So if you put the equation and the do now in your calculator, what does the graph look like? It's a circle. How does this equation differ from the equation of, let's say, a parabola that you've seen? We have both variables, x and y, both squared. So let's now graph this equation. List at least 4 points that lie on the graph of the circle. So if I just blow it up a little, you could see that it hits the x-axis at +5 and -5, and the y-axis at -5 and +5. So the 4 points I'll put are 5, 0, -5, 0, 0, 5, and 0, -5. How many solutions could we find for the following equation? Well, every point on this circle is a solution. So I'm going to plot those 4 points that I just wrote the coordinates of. And then as well as I can, I'm going to draw the circle. So you guys are going to have to be able to graph a circle next year and recognize the equation and all that. Up top, when I answered the do now, I really should have included 2 characteristics of the circle, the center and the radius. Those are the 2 things that we're going to stress every time we're talking about a circle. Where is the circle centered? At the origin, 0, 0. That's going to be the case for every circle we graph today. And the radius of the circle from 0, the center, out to a point on the circle is 5. How many solutions can we find for this equation? It's going to be infinite. Okay, every point on the circle. I wonder what the table of values, you're not going to be able to get a table of values because it's not a function, sorry. Why isn't it a function? Going back to algebra, doesn't pass the vertical line test. Parts of a circle, you could click on here and it's some geeky guy telling you about the radius, the diameter, and the circumference of a circle. Okay, so we have in the past looked at linear equations in the form y equals mx plus b. You've looked at parabolic functions that have x squared only, and now the circle that has both x and y squared. Okay, another very important thing about the circle is that the coefficients of x squared and y squared are going to be the same always. If one of those coefficients are different, it's going to be elliptical. It'll be stretched either wider or taller, and you'll look at that in Algebra 2 as well. But this year just circles we're looking at, so the coefficients of x squared and y squared will always be the same. So the general equation has x squared plus y squared equals r squared. That's when the center is the origin, which is the only thing you're going to look at today. The radius is the square root of whatever it's set equal to, because that number represents the radius squared. So if you have an equation, here's your example, x squared plus y squared equals 81, you know that the center is 0, 0, and the radius is the square root of 81, which is 9. It's not always going to be a rational radius, but in this case, if you have a perfect square there, you're able to get the square root. Okay, let's click on here. I can't, so I have to go back to I have it right here. If you guys go and to that link, I don't know if it's active or if you have to copy and paste it, you're able to change the radius of the circle, and it tells you to the equation, either in the picture or on the right. It says in the directions, make the radius equal to 7. And if the radius is 7, you should see something like this, where you have the the equation x squared plus y squared equals 49, which should make sense if the radius is 7 and you understand how that equation comes about. So write the equation of the circle. It was, oh, no parenthesis, x squared plus y squared equals 49. What are the coordinates of the center? The center, again, was at, oh wait, where was I when I clicked on that? Oh, here. The center was at 0, 0, and you could see that the radius, well, we put the radius in. So the center is 0, 0. What is a point that lies on the graph of the circle? Going back to it, we have the 7, 0, negative 7, 0, positive 7, 0, and 0, negative 7 as well. So what is the point that lies in the circle? I'll put 7, 0. Okay, because that's 7 units to the right of that 0, 0. We'd also go 7 units left, 7 units up, and 7 units down. So you can type these equations into the calculator. Again, they are not functions. Circles do not pass the vertical line test, so they're not functions. You can't get a table of values, but you could look at the points on the graph. Find the center and the radius of the circle. So we have your general form here. On the left-hand side, x squared plus y squared means that the center is at 0, 0. And if it's set equal to 36, again, you're going to have a rational radius because the square root of 36 is an integer 6. Find the center and the radius here. Again, we get the 0, 0. And since it's set equal to 40, now we're going to have an irrational answer, square root of 40. Sometimes they'll say simplest radical form, so I would break it down to square root of 4, square root of 10, which is 2 radical 10. So you're not always going to have a rational radius if, in general form, x squared plus y squared equals a number that's not a perfect square. All right, so now again, the center is still the 0, 0, but now we have a coefficient other than 1 in front of x squared and y squared, which makes it still a circle. The only difference is that they both have the 5 in front, though they should still have the same thing, same number in front. So out of curiosity, you guys could graph this. You could always graph it in the calculator and notice what it means. The center is still at 0, 0. Oops. And what's the radius? If you look here, where is it crossing? At 4. So how would we be able to get that the radius is 4 from this equation? What would it normally be equal to get a radius of 4? Well, that's the square root of 16. Well, when you're in general form like this, I could divide everything by those coefficients and then get x squared plus y squared equals 16. And then I could take the square root of 16 and get the 4. So anytime the coefficients are not 1 for both of them, you could divide it like that to see. And again, if it's a circle, the coefficients are always going to be the same. Here, it doesn't look like the general or standard form, rather, of the circle. In order to be in standard form, you have it set equal to r squared. So what would I have to do here? I'm going to add the 484 to both sides. So I'd get 4x squared plus 4y squared equals 484. And then I could divide through by that coefficient 4 and get x squared plus y squared equals 121. So the center again is 0, 0, and the radius is the square root of 121, which is 11. All right, now the opposite. If they give you the center and the radius, are you able to write the equation? Sure. If the center is at 0, 0, you're going to have x squared plus y squared equals the radius squared, so it will be 13 squared. So I'll have 160. 169. Why are I blanking out? Yeah, it's 169. Okay. And here, center 0, 0, giving us the x squared plus y squared equals the radius squared. If I take the square root of 18 squared, the radius squared, that gives you 18. Anytime you square a radical, you get the number underneath it. So that's just going to be 18. And finally, a little trick. We have center 0, 0 still, so x squared plus y squared equals, you want the radius squared, but they give you the diameter. So if the diameter is 20, the radius is going to be half of that, which is 10. And then we could take the radius squared and get 100. So that's what I would set it equal to. Shh. So that's your general equation of the circle. Here now from a picture, could we get that the center is 0, 0? And that the radius is equal to, from the center out to a point on the circle is 4. So I'm going to put x squared plus y squared since the center is the origin, and then get the radius squared, which in this case is 16. And that's your equation of the circle. Okay, sorry for the little interruption. Try to practice now.